You know, I don't mind naming names. Huawei was, I think, the best one. All Sungrow do is they turn off the export limiting, no problem, which is a bit of a problem. We shouldn't be doing stuff like that. I can't do that with Fronius, right?
Look, you could do it with Tigo,
no, don't do
etc. But
you could do it. I recommend you don't. Almost every other inverter, I will say, except for SMA, are pretty average at their maximum power point tracking, which I find really curious. Like, it's just an algorithm. I go 100% Fronius for a reason. It's not perfect. There's always issues. I'll be honest with you. As soon as a better inverter comes out, I'll jump ship too. You know? Okay, today we're going to talk about the Fronius inverter. And Fronius has a really good reputation as an inverter, but is it really better than the rest of the inverters on the market? So I've brought in today Rod Duer from Fronius. And we're going to talk a little bit tech about the differences that Fronius has of other inverters.
Yep.
Now, if people know me, they're going to think that this is just going to be a fan club thing where we're just going to be talking. I'm going to be totally biased and talk about the positives, but I'm going to have a crack at you too, Rod, or the product anyway. Maybe not you personally. If that's all right.
Yeah, go for it.
Okay, so we're going to talk about probably almost the elephant in the room, what Fronius always gets a bad reputation for, I think. And in fact, I was on Facebook, My Efficient Electric Home last night, and I saw someone ask the question, is the fan noise of Fronius as bad as everyone makes it out to be? So this is what we're talking about. I guess the first reason is, why is this a Fronius issue and you don't hear other, Sungrow or Huawei or anything else have issues with noise?
Yeah. So we still, even now when I speak to the R&D guys, make suggestions about doing fanless inverters. So most of the other companies use fanless inverters, at least on the outside. Quite a few of them still have a fan inside. So it's not as if they're totally against fans. We've looked at this over many years, and we still come down to the conclusion that active cooling is still the best for the electronics. We've done multiple measurements of competitor inverters and also internal testing of ourselves. It's just the components just do run a lot cooler, and you don't need to run them as close to the upper spec, let's say the spec 4. And so it's the longevity of the inverter in total. So, when we design products, we do design it for a 20-year lifetime as part of our sustainability as well. And so hence we want to treat the internal components as gently as possible.
Yeah. And I've done a lot of testing on this too. Downstairs, underneath my stairs, I've got this like little hot box set up where I have multiple inverters running. And they say, it's just a rule of thumb, this is not scientific, but for every 10 degrees hotter electronics is running, it lasts twice the lifespan.
Yeah.
Or the other way around, you know what I mean? Yeah. So I've found inverters running 10 to 15 degrees hotter when they've got exactly the same load on it, right?
Yeah, I mean, that's the thing with all the tests and things that we've done, looking also derating curves as well play a part in that. So especially when you get to commercial inverters as well. So it does definitely play a part. And it's not as if, we don't keep pushing from the outside and from the market, the market feedback that for some people it's a bit of an issue. So we're just trying to optimize that in making it a bit quieter, if possible. So, which we've done with the Gen 24 range, and etc.
Yeah, no, definitely. And so that's one thing is this is the old Snap inverter, which is behind you, which there's still some of, but that's sort of a transitioning out inverter. It's been a great inverter, but if you put this in your living room, it's probably a dumb idea, or next to your Barbie or something like that, in your garage where it's going to echo up the stairs or something, and you've got a big inverter, you've got to be careful about where you're going to do it, because bigger inverters, more fans, you're going to get more noise.
Yeah.
But the Gen 24, so let's just take this cover off here. I've shown this plenty of times, but that's the fan you've got there compared to this, right? So advantage of that?
So the advantage of a larger fan is it doesn't have to spin as fast. You can see the blades are a lot larger as well. And you can see the design, the actual design of the curves and how the heatsink is actually being manufactured. Is a highly optimized way of cooling. I mean, that was probably one of the main, if people did complain about noise, is the pitch. That's obviously still not totally quiet. You can hear it a bit, but it's reduced a lot as well. And also this actual sound of the noise is not as annoying, if some people want to put it that way.
We've installed over 4,800 Fronius inverters. Shane, my service guy that we're talking to just before, reckons that we've replaced about a dozen of these fans.
Yeah.
I don't think that's a big issue, but it can be an issue, I guess. Okay, now let's get On to the next topic that's maybe not too technical, but something that customers often ask about is monitoring. I really like the Fronius monitoring platform. And, as I test and compare other inverters, that's one thing that I do because that's what the customer sees and experiences. So for me, the Fronius monitoring platform is really good for the end user on the front of it, and then really good for me because I can dig down deep really easily and find out all your currents and voltages and all that sort of thing that helps us to fault find what's going on,
Yeah.
Whether it be with the panels or an inverter or maybe no problem at all, problem with the grid, whatever it might be,
Yeah.
A lot of customers ask about individual panel monitoring. What's your take on that?
Individual panel monitoring is mainly done via MLPE products, so modular level power electronic products. The disadvantage of that is you're putting more electronics on the roof. So as you know, I mean, especially in the Australian sun, for anything out in the open, the weather is going to, get a hard beating. Look, there may be some advantages of actually seeing what the panel's doing, but I think the disadvantages are still too high at the moment. The measuring device is more susceptible to going faulty than actually the panel. A little bit like measuring a ruler with a banana is kind of the way with that. So if at some stage going forward, there was, let's say, a standardized way, a definitive standard where you could use information from panels and they were built in with minimal extra electronics in there, then it's maybe something which would be an advantage.
I definitely agree. And I've gone through the optimizer saga, over the years, installing many of those. And I think you're really doing optimizer level monitoring, not panel level monitoring, because it's the optimizer that fails. I would say I've got to be fair to Enphase. It's a little bit of a different case for them that they don't have extreme failures as other rooftop power electronics do. But still, like theoretically, I don't really get the idea of putting rooftop power electronics out in the hot Australian sun. Each to their own. If someone wants that data, then, Fronius doesn't really offer it, I guess. So.
Yeah, no. I mean, look, you could do it with Tigo, etc. But
you could do it. I recommend you don't. Okay, now the next thing, we're going to get a little bit more techie here. Let's start off with MPPT. What the heck is that?
Well, it's short for maximum power point tracker. So solar modules have a certain characteristic when they produce power. It's like a curve, and it's usually the same kind of curve. So what the inverter does is it makes sure that the right combination of voltage and current gives you the highest amount of power. And that's adjusts because voltage changes with sunlight, with temperature, same with current. So these are two changing variables. And so the inverter needs to be dynamic and be able to chase that variable to make sure it's always hitting the right spot to get your maximum power out of your solar modules.
So it's tracking the maximum power point.
Yeah. So like as the name says, it's tracking it, it's following it, it's really trying to find where it is. Yeah.
And so I've done a bit of testing on this, quite a lot of testing. And when I'm comparing Fronius to other inverters, I'll be honest with you, when I started off doing this, I thought, well, I wouldn't find a difference. So what we do is we get up, again, two similar systems on the roof, maybe one with Fronius always, and then one with, let's say, Goodwe or Sungrow or Aiswei or something like that. I've tested bucket loads of inverters. And let's say I throw cardboard on it and I try to trick it with shade and then take the cardboard off and I see what the inverter does. And you would think that if I shaded maybe 1/10 of the array, generally speaking, we'd lose 1/10 of the power. So what I've found is both inverters go, they sort of lose where they're at for a second. And then Fronius quite often finds its path back to the maximum power point, and then it loses 1/10 or something like that straight away. Found it really interesting with almost every other inverter, I will say, except for SMA, are pretty average at their maximum power point tracking, which I find really curious. Like, it's just an algorithm. Can the Chinese copy that? I find it really weird. But there is a point that an inverter does get stuck, right? Like I was saying, where you throw cardboard on it, and then there's another level there that Fronius has. Called GMPPT. Can you explain what that does?
Yeah, well, usually traditional MPPT, so maximum power point tracking, as I said, you've got the solar panel has a characteristic, a curve. A normal one's they're fairly simple in terms of the way they look for that maximum power point. When you start to get something like shading, then that fairly distinct, nice curve that you would get of a solar panel, that really gets kinks in it, put it that way. So it gets all wonky. Yeah. And so that makes it harder for the tracker to find where's my maximum point, where is the maximum power. So what a global one does is it scans the whole curve. So let's say that whole characteristic right from top to bottom to make sure that it finds the highest point, because when it's disfigured and it really wonky, then it makes it very hard. There could be multiple different points where you have the maximum power. And so that makes it harder to find. So you need an algorithm that's very smart and fast at the same time and accurate to get the most out of your panels, especially when you've got a bit of shading.
Yeah, okay. And so if people understand the difference between power and voltage and current, you're really trying to find that combination of voltage and current that works best. And when shade is confusing, there might be multiple places, but there's one best place.
Yeah, that's right.
And the global maximum power point tracker, how often is that working?
With Fronius, about every 10 to 11 minutes it does that. So, and the reason for that is if you're tracking for the maximum power point, you have to go off it to try and find if there's another one.
Yeah.
So as soon as you go off it, then you're no longer on that point. So you need to do it not too often and you need to do it efficiently. So usually if you have some kind of shade, it's not something which is then there for a minute or two and then gone. Usually it's something from like a tree or a chimney or something like that, which with the sun it moves slowly. So there's no need to be overdoing it. So you need to get that right kind of balance of, okay, do it often enough that we find it, but then don't do it too often because you're making the whole algorithm inefficient. I've
told you about this test that I've done, which I thought was really interesting because Fronius only has 2 trackers or 2 maximum power point trackers. And so a lot of people think if you go east, west and say north with your panels, that then you need 3 trackers.
Yeah.
Well, you don't. But my thought was, well, let's say we parallel east and west, which is totally fine, but there's shade on one of them that we're going to have a real problem here and we probably shouldn't do that. I did some really interesting tests and I think I need to actually do a recording about this where I thought, okay, in some cases we're going to need, there's all these 3 tracking inverters are coming out like Goodwe.
Yeah.
And Fronius is sort of saying, well, we don't need that. And I'm like, oh, I think you do. You know? But so I did these tests and thinking, well, maybe we need to bring on Goodwe or a 3 tracking inverter in these really complicated shade situations where we've got panels in 3 different orientations. And I was really surprised to find out that not only did Fronius not suffer more than Goodwe, but Fronius was outperforming Goodwe when I was trying to trick it in 3 different orientations of unequal shade.
Yeah, right. Okay.
Probably a test that I need to bring out. It really blew my mind about and maybe drove home to me how superior I think the Fronius algorithm is or whatever it's doing. I don't know what it is. You know? So,
We've done some white papers and also our own tests. So, I mean, that's not an uncommon question. We've had that in the past as well. As soon as you have 2 parallel strings, there's shading on one, won't that pull down the other one as well? But it's actually not so much the case because it finds an equilibrium between the 2. So the losses are actually, of course, whenever you have any shading, that's the other thing you need to know, you're always going to have losses. It's about how it can cope and reduce the losses. Okay, now we're getting a little bit more techie. My new favourite topic, I think, is AFCI or Arc Protect, I think you guys call it. Seen in some of your paperwork? Yeah, it could be.
Something like that. You know? So, What is AFCI?
It's short for Arc Fault Circuit Interrupter. Basically what it is, whenever you have DC, the potential to have arcs can be there because you don't have alternating current. It's like a listening device, you could almost call it. So a listening device listening to the DC lines to see if there's any noise on there. So whenever you have, DC is direct current, so that it's just, flat kind of thing. There's no harmonics or anything or noise.
Sure. Yeah.
And so whenever you have an arc, then that's like a high frequency, like a radio signal you can kind of compare it to.
Yep.
So, and we're detecting those signals. Whenever you have an arc, I mean, that can be dangerous because you could, causes heat and then it could cause something to melt or, could actually, cause, damage to a system or worst case fire, I guess. With arc fault detection or AFCI, what it does is it's constantly listening or measuring that. If it detects it, what it does is it disconnects the power from the inverter. And so the current has nowhere to go. It sends out an error notification to let the system owner or whoever's monitoring it that it's picked up an arc.
I said it was one of my favorite topics. And I think the reason is that I used to do Enphase, right? And Enphase is known as one of the safest. You don't have DC voltage running down through the house. So it's as safe as. And there's always this theoretical issue with string inverters that Enphase will bring up all the time, right? Is that you've got a high voltage DC that can cause an arc. I reckon we've done about 15 or 20,000 string systems since we've started doing solar. We've only burnt one house down. No, I'm kidding. We didn't burn it down. we didn't. It was a house fire. It had nothing to do with us, But we don't have these issues, right? This is not a common issue. But there is a theoretical issue there. And I guess if someone's been in a house fire before and they're paranoid, they're thinking, well, I just go, okay, go Enphase. Like if it's going to help you sleep at night. I think this AFCI has kind of closed that gap and it's kind of saying, well, if there is any kind of theoretical problem there, if there is a really bad installer that does a really bad job of joining an MC4, then that will pick it up and you're going to prevent that. The inverter's going to turn off before you have an issue.
Yeah, that's true. Like you said, the amount of issues that have caused by fires through that is extremely low. And the other thing which some people bring up as well, AFCI, and this is again a bit kind of technical, it'll shut the inverter down, but you've still got the high voltage there. So you could still have arcing. The thing is that 99% of arcs are serial arcs and not parallel arcs. So because it's in series, as soon as you disconnect the power to the inverter, then there's nowhere for the current to go anymore. So the current is, and that arc is fueled by current flowing through it. So if you cut off that main current flow, then you'll cut off the arc. So
I've done testing on earlier ones of this, and it's kind of like the GMPPT. Everyone might claim to have one, and some of them don't. It's like AFCI. Some of them claim to have one, and they don't when I test it, or they're not as good. By the way, Huawei was, I think, the best one. Fronius have been working on their algorithm and really cautious, I guess, about bringing this out. But the last time I've tested it, it's perfect. I can't create a fire if I try to.
It's like it is a little bit like a black magic type of art.
Yeah.
Just because you have arc fault detection or AFCI doesn't mean, that they're all the same.
Yeah. No, for sure. And I was surprised to find that myself. Okay, one more point that is a little bit of a tension, I guess, is the security versus the functionality of an inverter. So I'll give you one example, and I don't mind naming names. A couple of years ago, we stopped installing Sungrow, and it was around about these sort of issues, is that we had inverters that were export limited. If you don't know what that means, I'll link a video up there. But it's just a function of the inverter. And the inverters were supposed to be export limited, but the inverter was having issues with that. So all Sungrow do is they turn off the export limiting, no problem, which is a bit of a problem. We shouldn't be doing stuff like that. I can't do that with Fronius, right? And neither can really Austria do that with Fronius. If we went to war with Austria, could they come and hack all our inverters?
We're very conservative and very concerned about cybersecurity and just security in general of IT or IoT products. We can, if need be, for a very short time, get in and do some analysis if we need to. However, there's a big process behind that. So first of all, we need to know which system it is. So Fronius Tech Support, we allow it or permit it at our end first. And then the end customer or installer needs to on-site activate the remote control at that end, and then we can actually see it. No one can just go in and just activate that. It'll come up as unable to connect, etc. So that kind of two-way authentication is very important. So you don't have a fleet of inverters unnecessarily reachable from the outside for no reason, because it's all increases the risk of a widespread hack or something like that, especially in this day and age. And it's not necessarily also always about the protocol or encryption or authentication. Part of cybersecurity in general is it goes right across the whole organization. So it is about the protocol you use, is about the authentication, encryption, all these kind of things, but it's about the internal infrastructure of the company as well. Like, who's got access to this? Have they been screened? What kind of access do they have? What do they need to go through to get access? All these kind of things. So we take it really seriously. And so hence we make it very difficult or not possible to actually do. Although I can imagine from an installer's point of view, it's, if you get something, it must be really handy to log in remotely and do something. But that can come at a price. So look, we're always analyzing or weighing up how much control can you get from the outside as versus security. And I guess we always side on more of the side of caution, especially today's day and age.
The obvious downside to that is load control. So Fronius has a relay built into their inverter that we can really simply turn on off on a hot water system when there's enough solar. We haven't used that for years, and part of the reason is I can't adjust it. If the customer calls up on a Sunday and is like, I run out of hot water, we can't help them out, so we have to talk it over the phone. We have to fault find over the phone. We're using a lot of catch power relays at the moment, which is a great device, because if I wanted to now, I could just go in and flick on my customer's hot water. They call me up. No worries, man. Sort of not such a security issue there. We're talking about hot water, but that ability to go in there and have that functionality to help out your customer is obviously a pro of that as well.
Yeah, 100%.
Okay, next point, Rod, and this is a bit of a problem that I have got with Fronius, or especially the Fronius and BYD combination. So let's say I've got a BYD at home and I go into a blackout. I'm not going to get a notification to tell me it's gone off, am I?
Yeah, that's correct. Yeah, you won't. You'll get potentially an email, which would come through if the router was on the backup side of things. So you would get an email, but it wouldn't be like an instantaneous one that you would get.
Yeah, right. And I guess when I compare it, like obviously I really like the BYD Fronius combination and I like Tesla. They're the two batteries I do, and I'm not going to do any more until something better comes out. Tesla just gives you a nice user interface. You get notifications come up and to tell you everything that's gone on. The Fronius app or the Fronius Solar Web and everything like that is really great. The interface that it's got with BYD has still got a bit of work to do, right? Yeah. And the other point that we get from customers a lot is depth of discharge. Can you explain what's going on there?
I guess that's the amount of usable energy within the battery. So, it's a state of charge, SOC can be 100% out of the box, and depth of discharge is how far that you can get down to zero. There's some things that are used in the battery calculation. So let's say at the bottom, so the BYD has a minimum of 5%, and that 5% is still, it might not be useful for the customer, but indirectly it is, because you need that 5% to keep the battery alive and keep it healthy. So it's part of the battery.
So, and we can change that. So if I went on, if I go and install a BYD today for a customer.
I say in terms of reserve capacity, yeah.
Yeah, so I can go and change it. Well, for Tesla, let's say it's going to be a storm tonight. I could just go into my Tesla app and hit storm mode, and my battery will keep the 100% charged, ready for the storm to come.
We are pushing for that internally with R&D, and so it is something which we have on our roadmap to bring out, like a storm mode button, where you can also easily change the reserve capacity and also set what state of charge or level of charge you want to have up to what time.
Yeah, we were talking about this last week actually, that as we're doing more and more batteries, and what happens when we start getting blackouts and things like that, and we now want to support our customers. And I'm thinking I need to make a video to explain to customers what happens when each of these go into a blackout. I don't think I really need to do one with Tesla. It's just so customer friendly, right?
Yeah, no, that's
BYD, and I will be working on that. You've got to know a little bit of what you're doing in order to manage that in case you overload the battery. If you want to set the reserve, well, currently you can't. But probably some improvements that hopefully we're going to see that one day.
Yeah, well, look, don't hold me to it, but look, there's something we're trying to get through by the end of the year. But we'll see how it goes. It is one of the high priorities for us to do.
When that happens at some point, is that going to be retrofittable to the past customers?
Yeah. So we'll make that as a software update, and then via, let's say, it'll be app for your phone, etc., because that's where most people will be wanting to do it from.
And obviously I go 100% Fronius for a reason. It's not perfect. There's always issues. I'll be honest with you. As soon as a better inverter comes out, I'll jump ship too. But at the moment, I think it's the best inverter on the market by league.
Yeah, like I said, we're always happy to get feedback. We're not perfect. And so, our customers, installers and end customers are our most important assets. So we really listen to what they say and try and implement what we can to make that experience better. So
yeah, good stuff. Thanks.
No worries. Thanks for having me.